Yes, minus 1, 1. Try to create an array with some values in it.
Oh, was it? What is?
It
wasn't there before. So let me
no.
create an array.
No, use np array. np.array.
Yeah. Empty.array.
No, np array, np.array. And
Oh,
pass it
okay. Yeah,
a list of values.
okay. What should I do?
Write np.array between the bracket you write.
Hello?
Yeah.
Can you say it again?
np.array between the bracket.
Oh,
You pass
okay.
some value.
Mhm.
Okay. So we got an array of 6 values. Okay. So we are going to reshape it. We pass a shape in this while. Okay.
Oh, okay. Reshaping, let me read. So basically, it's oh, okay. So this it make it to be it transform the matrix. Uh, it transform the vector. It's not matrix. It transform the vector, right?
What do you need to array? Okay. Okay. Uh,
So basically, it's
what do you need?
oh, so it's when it's try this and it's have 6. Oh, okay. I see what you mean.
Okay, right.
Oh, okay. So why is have like okay because it's an array, so there is no okay, so there is no
See what I was to talk to you in the bank. You see there, the first one, it is a rank unit matrix. And the second one, it is a column vector.
so the
In our case, for a column vector.
oh, okay. So the
In our
is
case,
the matrix.
A rank unit matrix, yes, it's like this, they call it in English. Yeah.
Sorry, can you type the word here? I'm not sure which type of metric you were talking about.
Rank unit matrix.
Yeah, I don't know that word. Oh, here, let me take a look. Rank unit. Oh, I don't really know this concept. Let me have a look.
Check that.
Because I have always thought that that is an array, you know. So rank unit matrix. Because I thought like since it's only have like this, then there's no matrix in it. But let me have a
Okay.
rank one matrix. Rank unit matrix. Okay, rank of a unit matrix. Hello?
I think that this is one of the better to know by.
Sorry, I cannot hear. You said like numpy, right? Let me.
I think it is a type of object to know by. Yeah.
Okay, so this one, right? I'm not sure. Okay, we can on that later. But this is not an array, but a
Yeah.
matrix. Is it an array also, right?
Yes, it's an array, but it's not. It doesn't help us to make our computation because it is missing the dimension, the second dimension. So the reshape help us to get the second dimension.
Okay.
I don't know if you understand.
Mm-hmm. No.
Okay.
Sorry. So you meant like these? Sorry, can you say it again, please?
The reshaping of the matrix using -1, 1 help us to get the second dimension of the vector. We need it to make our computation. Yeah.
Okay.
Because we make product of matrices, shape should match, have to match. Otherwise, we will get errors.
Oh, that's yes. That what I was getting error in my PySpark coding because I had the same issue. But then yeah, I have the same issue.
When you make a product, when you make the product of matrices, the number of rows of the left matrix should match the number of columns of the right matrix.
Oh, that's why. Now I figure out why.
The row
Here,
column-wise product.
hang on, give me a moment. Let's resume the recording. Okay, I got this. So why is it like? So after it's reshape it.
Say about the PySpark notebook.
Hello.
Okay, sure.
So after we reshape.
Yeah, you say that after later you reshape.
Pardon?
Okay. What did you say about the PySpark notebook?
Oh, don't worry about it. The server is not starting now, so I have to do some setting up. So don't worry about it. But I think once I got it set up, I'll ask you about the shape of the object. But right now, don't worry about it. So for this,
okay.
I don't understand like white here.
What didn't you understand?
Oh, I don't.
Train data price.
Yeah, so I know
for
the shape of this here, but I don't understand like what does this column do?
Okay, let me explain to you.
Mm-hmm.
Firstly, for fitting the model, we need two sets of data.
Mm-hmm.
The features and the variable we want to predict.
Oh, okay, I see. Yes, I think I got it.
You see the value, he could
Hello?
directly like train data. Yeah,
I'm
the
stuck.
first parameter he could give wait, I will send you something in the chat.
Okay, okay. Yes. Okay, so I think I got this. Okay, so basically below it's just evaluation and stuff like that, you know. So let's start with this.
Have a look in the chat. Have a look in the chat.
Okay. Oh, okay. Train data.
That one will be directly the first argument of our fitting function.
Okay.
Without needing to take the values and then need to reshape it again.
Oh, okay. I see. So, oh, okay. So basically, this is our feature columns, and we need to reshape it, and we need to put in.
Yeah, it is only one feature.
Ah, okay.
You could give it directly to the function. That if you take the values, it will be a rank unique matrix, and then you will have to reshape it again. If you don't take the values, give directly the series to the function, you will fit the model without errors.
Okay. Okay, I see.
Yep.
I understand now. Okay. So let's go. So basically, the rest of the book, I think I understand. They basically just you know, like plotting different. Oh, I have one thing to ask you about the box plot. Can you explain for me the box plot parameter? I don't understand like what plot is.
The box plot will apply it to quantitative variables. So the first argument should be the quantitative variables. In this case, we are applying to a data frame. So instead to give again the series, just give the name the function should have to look in the data frame. It is the price. So he take the quantitative variable price and then he plot it by zip code. The zip code is supposed to be a qualitative variable. So it will compute the distribution of values per each category in the zip code. And there we can see, we could compare the mean. The mean, it is the value which divide the box. And then at the extremities, we have the outliers and the others values. Generally, the values very far away from the mean are considered to be outliers. There is a limit, so it could vary. Generally, it is 1.5 times the interquartile, the difference between the third and the first quartile. The values in that range at the top and below are considered as outliers. You see, when you take the block plot, at the middle you got the mean, at the top you got the third quartile, and below you got the first quartile. And you see between the zip codes, it varies a lot. So the price of the house is not the same everywhere in the area used for the survey. There are places where the price is very high and others where it is very low.
Hang on, give me a moment. I will change my network. So I have a question though. So like the box, what does it represent?
Is it what?
The box, like the box here, like what is the high point and what is the low point of the box? Like for example, like this, you know. Like I don't understand like what does
Yes,
box represent?
I just said it. The below, uh, the lower bound, it is the first quartile. The upper bound, it is the third quartile.
What is the
The third quartile, it is that value which divide the population. When you take the third quartile,
I see.
you got 75%
Ah,
of the population having a value below that threshold.
okay. So
And then you take the first quartile, you got 25% of the population having a value below that threshold. It is
okay.
used for segmentation of the population
Mm, I see. So
across areas.
the upper bound is the first quartile, right? Quart.
The lower bound, it is the first quartile.
Okay, lower bound first quartile.
The
So
upper is the third.
fourth. Upper is the fourth quartile and lower is the okay. Okay. And so what is the dot here? Like you know, like let me draw for you. Maybe so you know like
Yeah, it is the values of.
okay.
Yes, it is the values. It is the values of the price for this zip code.
Sorry. So why there is dot and why they like the bar like this?
Yeah, it is the value of the zip code. The value of the price. You see, this upper bound completely below the last one, it is the mean value. The greater one is the max. So he
The upper.
wants in this one.
Okay. So this is the mean and this is the max, right? So this is the mean value.
The last one on the set, and the last one at the top is the max.
Can you draw for me? Like, can you highlight for me?
I have the control. Okay, you guys make a root control. Okay. So
Yeah,
here,
I think I. Oh, hang on. Okay.
okay, the maximum value for this zip code,
Oh,
the
okay.
smallest value for this zip code. Here you got, I think the second quartile is generally the median, and also if it is a normal distribution, it should be the mean. Here you got the third quartile,
Mm-hmm.
there the first.
First question. Sorry, I
Yeah,
didn't catch you on this. What did you say the line here?
it is the median, the second quartile. And if it is a
Second.
normal distribution, the median equals the mode equals the mean
Okay.
if it is normal.
So this is the mean, right?
I said the median, but it could be
Median.
the mean if it is, yeah, could be the mean if it is normal.
Okay. So in here, like, where is the mean? Like, what does it? Where is it? Demonstrate?
What does it demonstrate?
Oh, I mean, like,
Uh,
the mean in here, like, is it this one? Like I'm like, if I look at this chart, like, how do I know where is the mean?
on this one, you can't. Let me check. Don't tell me said mistakes. What position of the mean? I don't think that is the mean.
Mm.
Don't make the mistakes. Okay. Maybe I could share you my screen.
Okay, sure.
Mhm. Okay. Could you see it?
Okay.
You see my screen? Hello.
Yes.
Okay, great. So this is the box plot. There is this part. Here you got the interquartile range, which is the difference between the third quartile, upper quartile, and the first quartile. They call it here the lower quartile.
Mm-hmm.
There you got the median. And we call it normal distribution. It's a distribution which is secret. There is as much right than to the right side. The median equals to the mode equals to the mean. Otherwise, it's just the median. It is the value we divide the population in two samples of same size. There you got the largest value in the sample, and then you got the minimum. And when it is out of that, you got outliers. You got me?
Mm. Yes, I think I understand.
The plot you made helped you to compare the median across the different zip code to see if the price depends on the area where the house is. In this case, it's 2. There are places where the median price is very low, other places where it is very high.
Mm-hmm.
And the second aspect of that, it helps you to detect outliers. House for which we got a very high price, a house for which we got a low price, and in which areas we meet them.
Mm-hmm.
Maybe you have to make more research to explain what you observe in this data.
Okay, sure.
Yeah.
Okay, let me share my screen again.
Right.
Mm. Okay, so I think I understand this. So basically, the rest is just like explain the data. So I understand this. So let's do the quiz. We will have to code to get the answer. So I already got the first one. What part of the house? Okay, so let me go back to it. Mm. 2000. Okay, so I filter it out here. Let me see what does they mean by what part of the house. Yes.
You have a question here?
Oh, okay. So I count. I need to count the number of the house that fit with the condition. Mm.
No.
So basically, I need to get a number of the house that fit between 2,000 and 4,000, and then I divide it by. Oh, I need to get the total data and
I think they just asked to get the total data. I don't know. I don't see the question.
Oh, here is the question.
Okay, what part of the house people can live between 2,000 square feet and 4,000 square feet? Filtering the data. Okay, you filter it, and then you have to count. They said what part of the houses people can live. Okay, so they need a proportion.
Mm-hmm. Oh,
Get the
check with my
proportion.
classmate. So it meant that I figure out sorry, I think my voice has some echo.
But I got you. Don't worry.
Okay. So basically, I need to divide the number of the house left with 2,000 and 4,000. And then I need to divide this number to the whole number of the house. So let me do.
Before to code, try to think about the problem in the reality. You have first to count the number of houses who match the condition and divide by the total number of houses.
Yeah.
That's not the answer. And I don't think that you need count. You just need shape to count the number of rows.
Yes.
What you wrote, there is no condition inside.
Oh,
And
so I need to do this.
there are two things you need to know.
Yes.
What is this?
Oh,
What is the meaning of the value you just print?
so the total of the total data that available here, right?
Okay, yes, it is.
So I need to get the shape of this and divide by this. Huh?
Yes, divide by the last one.
Oh, wait. Two.
Yeah, you see the last one is a chopper. We find an index 0, it does get one element.
Hello?
This one's the chopper. You have to subset an index because it just gets one element. We are trying to divide a chopper of length 2 because the first one, it is the numbers of rows and the numbers of columns, the number of columns, by a chopper of length 1. It's not possible. You have to subset the first one, taking the first element, and subset the second one, taking the first element. The first element is generally the number of rows.
Let me think. Do it.
What do you have to use to take the first element of a chopper?
Pardon?
What should you use to take the first element of a tuple?
Oh, I just said it. So, oh, okay. So, I do this, right? Did I get the?
No, you have to write back to dot shape. Print it. No, print the shape, just the shape, yeah. So you get 9,214 houses matching this condition over the 2 million ones available. So you take the first value, like you did before, yeah, and you divide it by the total number of houses.
Okay.
No, for the total number of houses, yeah, just that one. No, you take the shape and you take the first value in the shape.
Yes.
Dot shape.
Okay. Okay.
So 143.
Okay. Between one trend. Hang on, let me read. Between one trend and value. Okay, let's see again. Oh, we can do this. Okay, let's see. Okay, IMSB is 248. 248. Let's see what is the order.
Is it possible to do it tomorrow? I've got a meeting in 15 minutes.
Oh, okay, sure. Okay, I'll see you tomorrow.
Okay,
Bye
great.
bye. Thank you.
You're welcome. Bye.
Bye.
Have a nice Saturday.
Yeah, thanks you too. Au revoir.